Good morning, everyone. First, announcements. Today is the due date for your homework and your quiz, so please do not forget to submit homework and quiz C++. Now, previously, we start with LISP. LISP, what we know, most important thing, do not have data types. You do not have to worry for type matching. Number two, the syntaxes. The syntaxes, all the rules that you learn regarding Java, C, C++, all this complexity of the different symbols, square brackets, curly brackets, semicolon, the dot, commas, and so on, is gone. The only thing that you need to remember regarding the syntaxes, the important things, everything starts with a parenthesis, everything ends with a parenthesis. Everything is not use the mathematical expressions. Second, inside of the parentheses, never you have commas. There is no commas inside. The elements inside of the parentheses are going to be used something, white space, something, white space, something, and you can continue. Parentheses, elements inside. This is what we call a list. Elements inside of parentheses separated by white spaces is a list. And the name of the language is LISP, list processing. There is a reason for it. Now, in a list, something that we have for the instructions is this element, the first one in the list. The virtual machine understands that that one is going to be the instruction. You want to do something, you want to do an addition, a multiplication, print something on the screen, a square root, whatever. The instruction is going to be that word, the first word after you open the parentheses. Now, in other languages, it's always a word. Here, in this position, as we noticed before with examples, and today we're going to review more examples, you can put a plus, and that is the instruction for addition. Or you can use SQRT, and that's in the instruction for a square root. Moreover, something that we review, for the first time, we have a programming language that is not case sensitive. So this instruction or this instruction is the same. Or you can play with a combination of upper and lower cases. That first element, after you open the parentheses, is the action that is going to happen. It's called the function ID. The plus in Java and C++ is an operator. In Lisp, it's a function ID. It's the name of a function, similar to SQRT, similar to print, and others that we review. Anything that you put after that, all of them, arguments or parameters, parameters for the function, whatever function is here. How many? As many as you need, as many as the function need. No parameters is fine. Use inside of parentheses the name of the function, or you can add one more, or two, or three, or continue. What we use inside of the parentheses, what we use as a parameters, well, the first thing that we can use, not the only one, but the first thing is values. And in the previous lecture, that is what we reviewed, values, atomic or primitive data. Important things that we reviewed previously here, you have negative numbers. Here, something that I mentioned, and I want this to be clear. You have negative numbers, they are one word. It's not the minus unary and the integer 3, it's just one word, -3, atomic expression. In the same way that I mentioned the negative numbers, I need you to consider these ones. Is not a division, is a fraction. The language support the use of fractions, and they are primitive values, just like the integers or the floats. Negative numbers, fractions, moreover, in the same line, complex numbers. For the first time, we have complex number as a primitive element in the language. Excuse me. You can have classes to create complex numbers in C++ or in Java. Here, it's just a primitive element. The complex number exists, like the fractions, like the integers, or doubles, and so on. Obviously, you have floating point numbers with the dot or with this notation with the E. Both are valid, and you can use it in Lisp. You have characters, and something that we review quickly, the characters, instead of having something inside single quotation marks, something inside of the apostrophes, here we use the sharp, the backslash. This is the replacement of the apostrophes. And whatever you put inside, like the X, well, now it's going to be at the end instead of being in the middle. You create characters with that. Also, you have the escape characters, as you remember. Now, instead of using only one element like \n or \t or \b or all the others that are the same Java, C++, here, instead of use one letter, we can use the full name. For instance, the chat, /tab. And all of that is the equivalent to this. All of that is one character. The name of the representation for one character. Similar, instead of having the white space in the middle of the quotation marks, we can use space. Full name. Atomic. Also, we review strings. Strings work basically in the same way that they work in the other languages. Quotation marks, something inside. If you want to use quotation marks inside, or if you want to use special characters, the ones that we use for other things, you need to put a backslash before the character, like backslash before the quotation mark, or if you want to use a backslash, you need to put that twice, so it's not affecting the next thing. Use as normal. And maybe the most important thing that I mentioned, use at the end of the previous lecture, the boolean values. The boolean values, and I want to mention again, Java, true and false, C, C++, 1 and 0, numeric. Here, we're going to have this T, not true, T, and nil. Not null or false, nil. Remember those two, for sure, are going to be in your exam, maybe in a quiz. So, atomic expression, here we finish the previous lecture. Now, we can practice and we can put together these things and probably examples of these things, more examples, learn more functions, more instructions with Lisp, more things to do in our programs. Let's check. List. Question in your exam, what is a list? And I mentioned the answer before. Examples. You can put this line in the virtual machine, press enter, and this is going to be the result. Do we understand what is happening? Number one, if I ask you, that one is an addition. What I am doing is adding. Adding how many numbers? Hopefully you agree with me, 2 numbers. In particular, 2 fractions. If you ask Lisp to add 2 fractions, the result is going to be a fraction. You are going to notice fraction 1, fraction 2, and Lisp is going to reply with, well, your result. Lisp is going to try to keep using the same data type that you propose. So if you propose the use of fractions, Lisp is going to try to continue with that data type until something happens. Something happened. Somehow the result need to be expressed as a floating point numbers. In this case, well, it's going to switch to floating point numbers. But if possible, it's going to try to continue playing with your rules, with what you are using. So addition of fractions, just like that. Please remember, this here is not a division. If you want to do a division, then the instruction is different. For instance, you can do the division of 27 and 32, and that one can be one instruction. Also, you can do the division of 32, and that is another instruction. Moreover, if you want to do the addition of that, you can use them as parameters. Hopefully you notice what is going to happen. Here, the things are going to be recursive. Is one instruction as a parameter for another instruction. The inside is going to happen first, so the parameters are going to be solved first, and then the result of that is going to move as a parameter of the instruction outside. So in this example, the divisions are going to happen first. The result is going to be a floating point number, and then it's going to happen the addition of two floating point numbers. Here, what I am doing is the addition of two fractions, two atomic things. Here, if you think about performance, if you think about actions, here, by default, I am working with the numbers, the values. Here, I am asking for two instructions to be executed and then a third one. Two different things. Probably the result is going to be very similar. Probably the second one is going to be a floating point number. The first one is going to be a fraction. Depending on what you are doing, what do you need? Now, next. Similar idea, multiplication now. Multiplication exists in the same way as addition. And I have two parameters. Hopefully we agree with that. Now the parameters are floating point numbers. Floating point numbers, one used with the dot, the other with the I format. It doesn't matter, use like Java, C++, both are valid, both are understood by the interpreter. If you ask for the multiplication, the computer is going to give you a result. And even though the result have only the integer part, even though the decimals are 0, you are going to receive as a result a floating point number. A floating point number, dot 0. Why? Because your input is floating point numbers, the output is going to be floating point numbers. Just like before, the input are fractions, the output is fractions. Keep the same data type. That is what the computer is going to try to do. Now, moving forward, these two first examples is with two parameters. We are thinking they are binary operators. If we move forward, this one, multiplication. Multiplication, well, yes, but just like we reviewed previously with the addition, is one number here, another number is here. Notice that I have here a negative number, is one number. Again, is not the operator minus unary, is a negative number, one word. And the same here, is one number, a fraction, not a division. So I have the multiplication of those four elements, the final result, and you notice I have floating point numbers, I have fractions. So when I do the multiplication, the computer is going to take the data type that allows me more freedom, floating point numbers. instead of transforming all of these to fractions, this one is going to be transformed to a floating point number, and all the work, the multiplications, are going to be done with floating point numbers. Therefore, my result is going to be a floating point number. Good news, you don't need to worry about the casting. You don't need to worry about the transformation of the data types, but you need to be aware of what is going to happen according with the input that you provide. Anyway, division, just as mentioned before, you have the function division, and therefore you can express the division of two numbers. By default, if you ask for a division, LISP is going to play with you in this way. You are asking for the division of 3 and 5. It's a fraction, 3/5. I need to be clear. It's not like it's giving you the same. It's giving you the result. It's giving you a number, a fractional number. This is the instruction for division. This is a fractional number. It's going to tell you, why are you using division? Use fractions, at least for something as simple as that. Obviously, if we talk about division of different parameters, like this one being division, it's a different story. But when you do division of two numbers, the result, the immediate result, is going to be a fractional number having the two inputs up and down. If you go with division, but you use, instead of integers, like in the previous example, you go for floating point numbers, even if you only put the .0, I mean, even if you have an integer, but you put this fractional part, decimal part, automatically, the interpreter is going to understand that you want to do the division of a floating point number divided by something else, without any further consideration. Any division that include fractional numbers, floating point numbers, is going to give you a floating point number. So in the first example, 3 divided by 5 as integers is going to give you a fractional number, this one. In the second example, if you make any of the numbers a floating point number, just like this thing, your result move to floating point numbers. It's not a fraction anymore, because fractions should have both parts integer numbers. If not, you have a division. Moving forward, the last thing here, parentheses 1 plus whatever. I put this big because I want to be sure that we're clear. Here, 1 plus is one word. Those two characters, the number and the operator, are together, and this is the name of the function. There is a function called 1 plus. Yep, that is the name. And the second one is the parameter. Again, only the white space separate things. And again, if you have characters together from the beginning of the parentheses until you found a white space, everything here is together, is one word, and is the name of a particular function. And you're going to find crazy names, maybe like this one, 1 plus. And can you guess what is the meaning of a function 1 plus? Is something that we already knew, maybe? Yeah, correct. This is our friend, the plus plus operator. Now, something very, very important. The plus plus operator in Java and C++ can only be used with variables. Hopefully you agree with me. In C, C++, and Java, you can do x plus plus because the meaning of that is x equal x plus 1. So you need the variable. You cannot do something like 5 plus plus C or Java. That do not have a meaning in C++. C++, and Java, because you are asking for something like 5 equal 5 plus 1. So you're trying to use the number as a variable, and the compiler, the interpreter is going to go crazy. In Lisp, you can use numbers here. In Lisp, you can ask for 5 plus plus, well, 1 plus and the 5. And Lisp understand that, well, if it's a variable, you want this. But if you have a value, the only thing that you want is that part. Lisp understand that the value cannot be stored, the new value cannot be stored in the value. It's just going to do the part that can be done. So this work makes sense, right? 1 plus is the plus plus. Now you can use the plus plus with both variables that we need to review how to create variables here, and with values. You can create your function to plus. By default, like in the library, you have 1 plus, but we can create our own functions, and we can create something like 2 plus or 100 plus or whatever. Good. For the standard, 1 plus instead of plus plus. And yes, you have the minus minus too. Good. So I think it's clear. It's easy to remember. Use to let you know the rules. Open and closing parentheses, name of the functions, parameters. Everything else, the compiler, the interpreter is going to take care. Moving forward, other kind of instructions used to take a look to diversity. Number 1, this one. I mentioned this in the previous lecture. I want to show you the specific example. All of this, string minus uppercase, is one word. Something that I want you to remember, we mentioned before, the minus here is not an operator. It is not a minus. That line there is what in Java or C++ you use the underscore. Something that I mentioned before, I want to insist, if you are working with Java, you get used to do something like string uppercase, thinking like 2 words and the first letter of the second is uppercase, so just following what is here. When we move to C, C++, something that we mention is, well, 2 words is the first one, underscore. Instead of the first letter in uppercase and everything together and allowing the reader to figure out that there are 2 words because this uppercase, that is Java. C++ use this underscore. Lisp, instead of the underscore, is going to use this line in the middle, what we usually use as a minus. So string, line, uppercase is one word, one instruction is the name of the function that we want to run. And I am sure that you can guess that function, what it's going to do. Receive as a parameter a string, quotation marks, something, and it's going to return as a result the same string, but everything uppercase. Obviously, uppercase the letters, numbers and symbols, the same. The next one, reverse. One instruction, one parameter. Can we guess what it's doing? Reverse. All the letters in the opposite direction. This is my string, return a string with all the characters in the opposite. The last character becomes the first one, and so on. Just for fun. Another one, length. we have size and length, Java and C++, size. Here, easy. Length is the instruction, the function, one parameter only. And it's going to give me the length, how many characters. Square root, I mentioned this before, square root, uppercase, lowercase, it doesn't matter. However, usually what we do when we create programs with Lisp is we use lowercase. It just what happened. Did work, but usually if you read the book, if you search for source code available online, this is going to be the common, lower cases, even though the upper cases are also valid. Square root, you can ask for the square root of an integer number, and you're going to get a floating point number since the result cannot be integer, so we move to the next level. You can ask for the square root of a negative number, and in this point, we start working with complex numbers. If you try this with another language, maybe it could be an error. There is no result with floats, integers, and so on. Here, we have the complex numbers as part of the primitive data. So a square root of something negative, a complex number. The complex number, and as you remember, char C, parentheses, and inside the real part and the imaginary part. The result immediately, square root of -1, is going to give you the complex number. Moreover, you can use complex numbers to do addition, multiplication, and so on. So you can continue working your problem, and you are using complex numbers as an input for other operations. Similar with the uppercase, same result. And something that I didn't mention before, but hopefully you remember, here we do not have the semicolon because the semicolon at the end is not necessary. You have the closing parentheses. You heard me before, the semicolon here is the first element of a comment. So you are going to notice all these green lines with the semicolon at the beginning is a comment. The semicolon for your exam is kind of the equivalent of this in the other languages, is the element that starts a comment, and that comment is to the end of the line. Everything from that point to the end is a comment, so the interpreter is going to ignore that element, whatever you put there. Comments, instructions with strings, with numbers, fractions, complex numbers, and so on. Hopefully, until this point, everything clear. Any question? Good. Okay. Moving forward, parameters. Parameters, as we mentioned before, some functions like the one that I mentioned at the beginning, 2 slides ago, are going to have the opportunity to be as many parameters as you want. Some of them are in this direction, but others, like you can imagine these ones, only accept a limited number of parameters, a specific number of parameters. For instance, this one for the length, you can only put one parameter, period. You are asking for the length and you need to provide one string. It's not like I put 2, 3 strings and I am going to receive back the length of all of them. That didn't work in that way. Remember, a function returns one result, one and only one. So as many parameters as you provide, all of them should be used to get one result. That can happen in multiplications, additions, and so on. But for length, for instance, that not happen. You are asking for the length of one string, so you pass one string as a parameter. If you pass 2, it's a problem. The interpreter is going to tell you something. Similar with the square root, it's like I cannot use a square root and pass a list of 10 numbers. It's not like I am going to receive back the square root of the 10 numbers. So square root, one parameter, only one. Something that we need to do is to remember which functions accept more than one parameter, like plus, multiplication, division, which one do not. So the plus, the multiplication, check. You can pass as many parameters as you want. All of them are going to be multiplied. All of them are going to be added. Others, like the previous one, and also like this one, have one version with only a few number of parameters, or they could have a few versions. A few versions like this one. I have a version with 2 parameters, but also I have a version with 3 parameters. So it's not like I can use, like for the plus, any number of parameters. It's not like for the square root that there is only 1 parameter. It's more like what we know as overloading. I can use 2 or I can use 3. Both versions exist, and that's it. I do not have a version with 1. I do not have version with 4, 5, or more. It's just those 2 versions. Now that we are here, subseq. We talked about this before. A substring in a string. The first parameter always need to be the string. The second parameter is going to be a number. The important thing here is it's not only about the number of parameters, but also about the order. And you remember this from CSE240. The function is expecting a string as a first parameter. It's not going to work if you put the string as a second or last parameter. The first one, the string. The second one, an integer number. Cannot be a floating point number. Cannot be a complex number or a fraction. It's an integer because it's a position in the string. And there is this version that allows you to give a second integer number, also an integer number, a number of characters. I have a string and I want a substring, and the first number is telling me the first character that I want in the substring. In this case, something like that. And in the second one, well, it's not only the first one to start, but also in which place I want to end. So a substring, the beginning, at least 2 parameters, the minimum, to the end, or to a specific place. 3 parameters or 2 parameters. The important thing is the data types, integers at the end, the string that I need at the beginning. Yeah, we need to show you one. Moreover, there are functions with 0 parameters. We are going to create our own functions, and we're going to create one function with 0 parameters and function with several. So don't worry. Right now, I am showing you how to use the things that are in the library, but the most important thing that we need to review, and probably the next lecture, is, well, I need to create my own functions. And then I need to call my functions. And what about making recursive functions? Those are going to be the interesting parts. Anyway, this clear so far, functions, arguments. Now, important, the last thing. Every single time that you have a function and that function returns as a result nil or t, every single time that you have a function and that function returns a boolean value, and I need to be clear, I am talking about t and nil, the equivalent of 2 true and false, that function receives a particular name, predicate. What is a predicate in Lisp? It's a function that returns a boolean value. I need you to remember this because we're going to talk about predicates also in Prolog, our next language. And the meaning of a predicate in Prolog is going to be something different. Therefore, in your final exam, when you are asked about predicates, please remember in which language we are talking about. Predicates in Lisp is a function that returns a Boolean value. Predicates in Prolog, we're going to review that later. Predicate in Lisp, any function that returns a Boolean value, any function that returns t or nil is called a predicate. So, classical example, the equal. The equal is called a function. Is the function ID equal? You'd like the plus. This one in particular is a predicate. What is a predicate? All of this, because the result is going to be true or false. Important, guys. One equal here is what you know as equal in other languages. One equal is the relational operator. This example here is asking if those two numbers are equal. And I am sure that you're thinking like, what is going to happen with the assignation? Because right now you are using the assignation operator as the Boolean operator equal. So that means that you are not going to be able to use the equal to do assignations. What are we going to do with that? Don't worry, we need to review variables and we're going to talk about what to do with the assignation, but it's not going to be the equal. The equal is for relational operation. The equal is to compare things. The equal return true or false. One is the meaning of what previously we have with two of them. Good, a predicate. So in this case, obviously, if you ask equal and you put two numbers that are not the same number, like this 4 and 3, you are going to get as a result false in Lisp, nil, and in uppercases. As you notice, usually the results that the virtual machine provide to you are in uppercase. Your program uses lower cases, kind of a standard. So the computer, the virtual machine, use kind of uppercases to show you results, somehow to make things different. Anyway, nil. Similar thing with the other relational operators, lower than, greater than, lower or equal, and so on. They are function names. They receive two parameters. They return true or false, t or nil, t in uppercase also, to indicate that, yeah, the 3 is lower than the 9. Predicate, functions, not operators. We do not have operators here. Moreover, there are functions that are not symbols, but words. Something that you're going to notice in the functions from the library, from the API of the language, a lot of functions that return true or false, t or nil, they are going to have in the name a p at the end. The p is because predicate. So for instance, number p is like, okay, this is a function and I have no idea what this function is doing, but the p is telling me that it's a predicate. Therefore, when I call this function, what I am going to get as a result is going to be t or nil. T or nil, and the name is number, one parameter. The function is going to check the parameter and it's going to tell you true if the parameter is a number. It's going to tell you false, nil, if the parameter is not a number. Number p, and you are asking if the parameter is a number, yes or no. Number p. What do you think about odd p? It's a function. When it's going to return true? When it's going to return false? What about a function 0p, when it's going to return true, when it's going to return false. I am sure that you can guess. I am sure that all of you have the answer, right? You have functions that help you to know if you have a number. You have a function that helps you to know if your number is odd or even. And moreover, you have a function that is the equivalent to compare a parameter and tell you if that parameter is 0, yes or no. Instead of doing this, you do this, or equal or that. With the equal, compare the variable with 0 with a function and use the variable as a parameter. And those two are the equivalent to what you did before in Java, C++, like that one. Question for your exam, things that are going to happen is you are going to have source code in Java, in C, and we are going to ask you to translate that code to Lisp. Or the opposite, you are going to have code in Lisp, we're going to ask you to translate that to Java, C++. So that is the reason because I make a lot of emphasis in what is the equivalent between one and other language. Good. Try to practice that every single time that you are copy paste one of these sentences, every single time that you are practicing and checking what this is doing, think about how to write the same, how to get the same result with the same input in a different language, in all the other languages that we have reviewed. So far here, we're talking only about operators and functions. Later, we are going to start involving things like memory management, pointers, yes. Just keep thinking about it. Anyway, predicates, functions that return true or false. Some examples, relational operators in other languages. Here are functions, and there are also some methods, functions like this. They finish with the letter P. When you have something that finishes with the letter P, probably that one is a predicate, is a function that is going to return a Boolean value. Errors. Lisp is very similar to C and C++. There is a few errors that you are going to get when you are programming with this. A very, very limited number of errors. Almost anything that you create, the virtual machine is going to try to do something with that, just as happened with C++. This one, like C++, is not Java. It's not this very limited context in which everything that looks not so good is going to throw an exception or is going to give you a warning or a message that you probably need to review this. These languages try to work with what you provide. Now, errors that you are going to get for sure. Number one, maybe the most important, there is no solution for this, division by 0. Even though here you have complex numbers and fractions and so on, if you try to do a division of whatever, 0, the virtual machine is going to give you an error. There is no middle point like, well, maybe that one is a fraction and the fraction have the 0 below and something can continue. No, it's an error. And your error is going to look like that. When you do something that is wrong, what you're going to get, depending on the virtual machine that you're using, depending on your interpreter, but usually is this asterisk used to call your attention, and the error message is going to be very, very direct. One line, short, division by 0, done. You have a problem, you have a division by 0. Second, a common error. If you try to do like open parentheses, closing parentheses, and put something inside here that do not exist, because basically we can put everything inside of parentheses. What you put here, here, and here, the parameters, that can be almost anything. But the first element is the name of the instruction. A common error is what happened if I open parentheses and I put X. If the computer didn't know this name, if that name is not a function from the library, if the function there is not a function that you create, and we need to talk about how to create functions, but if the computer didn't know that function, you're going to get this error, and hopefully it's kind of clear. It's going to give you the name in uppercase, and it's going to tell you it's not defined. It's not defined is I do not know that function. Be careful. Usually happen if we forgot a letter, like maybe you want to do print. You forget one letter and you're going to get this error. Print is undefined. And if we do not review carefully, we could think that something is wrong with the interpreter. Nothing is wrong with the interpreter. If you get an undefined error, that means that the name of the function do not exist. If you think that the function exists, check again, maybe one letter, two letters are not there or are in a different position. The computer cannot find that function. Those two are the most common error that you receive, at least working with the exercises that I am going to show you, at least working with the homework that we're going to do. Be careful with the division by zero. It's an error. Be careful with undefined functions. Check and double check that the word after the open parentheses is something that exists in the library or in the functions that you're going to create. Good? Most important errors. They are not the only ones, but at least are the ones that usually you are going to ask us, the TAs or myself, about something is happening and I do not know what to do. Probably that one. Good. Now, easy. Moving forward. Recursion. And you notice, this language is all about recursive calls. This language is all about everything is a function, and a function, parentheses, can be inside of other parentheses. So your programs in Lisp are going to look like that line. And that line is an easy one. What is the meaning of that? I just want you to remember every single time that you have parentheses, you evaluate first the parentheses inside. A program in Lisp is going to be a bunch of parentheses inside of others. And always, 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 your program starts with the central part, with the thing that is more inside. And from that point, go out. First example, here, the first thing that you're going to do is this multiplication of a floating point number times 4. Whatever is the result is going to be a parameter, the second parameter for this addition. You're going to do the addition of 33 plus the result of that multiplication plus the 9. And you're going to get this. You have only integer numbers. The first thing that you do is the multiplication. Multiplication of floating point and integer is going to give you a floating point. And then the addition is going to happen integer plus floating point plus integer. You have one floating point, that is going to be the data type for the result. So you have the 0.2 there. Similar thing happen with other crazy things. For instance, I mentioned the instruction length before. Length with this string. That function is going to return a result. The result is going to be a number, the length of the string. That number is going to be used as a parameter for the plus, for the function that is outside. This instruction is going to do the length of hello world plus 44. The final result, 55, that is what is going to be printed. Notice, only the result of the last function or only the result of the full expression is printed. You do not get printed the partial result. Never, never, never you print, or the virtual machine print the result of this part, or only the length of the string. What you get always is the result of the full line, the result of the combination of all the parentheses that you open and close. Moving forward, the things can become crazy. And I need to ask you, it is clear that all of this subtraction, division, addition, multiplication, it is clear that that instruction is this. And I am asking because in your exam, you're going to have one or the other, and we're going to ask you to transform to the opposite. You're going to have an operation in Lisp, and we're going to ask to translate that to an operation in Java, or an operation in Java to the version in Lisp. It is clear what is happening. It is clear what happened when you put the operator on the beginning. It is clear that the last thing to happen here is the multiplication, just like here is the multiplication. It is clear that parentheses have here a highest precedence, and therefore this thing here, this addition, is going to happen before this multiplication. Moreover, that parentheses here have a precedence, and there that minus is going to happen before this division. One important thing, in Java and C++, you have precedence of operators. All of them are binary, but you know which one to run first because you learn the rules of precedence of operators. Precedence of operators, you learn that whatever is inside of a parenthesis have highest precedence. Then you learn that multiplication and division have highest precedence than plus and minus. Precedence of operators is important in C, C++, and Java. However, here in Lisp, two things. I cannot ask for the parentheses to change the precedence because the parentheses are everywhere. And the precedence, therefore, is use internal parentheses go first than external parentheses. What is going to happen here? What happened here is the operators are not in the middle. There is no way to read in different ways the operation because now the operators are at the beginning. And I know that the things that are going to happen first are the things that are inside. The things that are going to happen at the end are the outside. In the version in Lisp, I know that the last thing that I am going to do is this multiplication. Why? Because that multiplication is the function that is going to happen at the end because everything else are parameters for this function. Also, I know that inside of the parameters, the first parameter that is going to be calculated in some point, this one, in the same point, this one, but this one, the division, is going to be done. And it's going to be done using this subtraction as a parameter. Moreover, this addition is going to be done. And this multiplication is going to happen with the result of this addition and the result of this division. That is the multiplication that I am doing here. Moreover, the division is between this number and the result of the division. Hopefully you agree with me, but understanding the precedence of operations in Lisp is easier than understanding the presence of operations in the other languages. Is more clear, even though the parentheses are kind of crazy, but it's easy to know what is going to happen first. Moreover, it's easy to know what is the parameter of what. It's easy to understand that this 3 is the parameter for the division. That's it. 3 is connected with the division. 3 is connected with the division. I put parentheses here to help you to read, but you can agree with me. I can take this and remove all the parentheses, almost all of them, and the presence of operators is going to start working. With the other languages, we need to be careful with that. With Lisp, there is no way that I remove any of the parentheses. The parentheses are there not because the mathematical operation. The parentheses are there because they are part of the syntaxis of the language. Always, 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 I am sure about what is going to happen or what I am doing. Parentheses, operations, precedence. Check that. Moving forward. There is an instruction log, and you do not need the library math. In fact, you do not need any library. It's just available. Use like SQRT. Moreover, you can use the instruction with anything, including, and I haven't used this in a while, the long numbers. You can ask for the log of all of this, or you can ask for the log of 5. They just work. The same apply for the square root and the addition, subtraction, multiplication. You can work with small numbers, big numbers, no difference. And again, you can ask for the logarithm of the number, and then you can pass that as the parameter for calling the logarithm again, and the result you can use again. I am just playing with the function. There is no particular reason for doing this. It's just you can use one function, the result is the parameter to other, the result is the parameter to other, and you can play with big numbers with any function. Good. So working. You have both. You have what commonly is the log, you have what commonly is ln, and you have also the log with the base 2. So the 3 of them available. Similar, sine, cosine, and you can imagine tan. Moreover, you can imagine the arc. All the 6 trigonometrical functions are available, and they work as described before with floating point numbers, integers, or even something crazy like that. Something that I need to mention here, another common error, warning, quotation marks, is the following. One advantage of Lisp is the capability of work with almost any kind of data. However, not everything is beautiful. If you play with this, and it's just one example. If you play with this, your expectation, well, if you do this with your calculator, if you calculate this in your math class, your expectation could be something like close to this number. If you run this with Lisp, you are going to have a small mistake. You are going to have these small differences for some operations in which maybe you expect a result of 1 and your result is going to be a crazy thing like this, or the opposite. Maybe you expect a result that is just this or 0.333 or something, and you're going to get a result that is a 0.4 or 0.34. Those kind of things, the problems with the precision of the numbers is something that happens where you are dealing with virtual machines. This happened with Lisp, and there are also examples of these kind of problems with Java. That is the same with the virtual machine in Java, the virtual machine in Lisp. You are going to have cases in which the precision of the numbers is not what you expect. You are going to have cases in which you know that the answer is 1, but you are not going to get that 1 as an answer, but you are going to get something very, very close. If that is your final result, nothing happened. If you're going to use that result to multiply times 100, well, you know that you can expect the error to expand in your program. So be careful. Virtual machines and the precision of the results is sometimes an issue. Yeah, the ln. Good. So be careful with this, with the numbers. Moving forward, similar, the recursion happened with predicates. So if you remember in Java, C, C++, all those crazy things like A greater than B and C lower than D, this combination of relational operators and logic operators, well, you can do the same here. And or not, you know what? This guy do not exist. Now the operator and is and. These two bars do not exist. Now the operation for or is or. And this exclamation symbol is not, so not. This one is that one, and hopefully you agree. Moreover, hopefully if I give you this, you can give me that one. The first thing to happen here is this multiplication. So I have this multiplication. Then I need to compare if the multiplication is lower than 3. Lower than 3, the multiplication. So this one is this one. And then I want to do an AND, but the priority is the not. The not have higher priority. So because it have higher priority, this one, the not is going to happen first. Is going to happen first than the AND. And 2 greater or equal than 6, greater or equal, 2 and 6, and not that. And those two together inside of an AND. By the way, the first time that I use the enter, you can use the enter in your virtual machines. You can start open parentheses, start writing. Your line is going to be full. You can press enter and the virtual machine is going to allow you to continue writing because the virtual machine knows that you haven't closed all the parentheses. As long as you have parentheses open that you have not closed, you can continue creating multiple lines. It doesn't matter how many times you press enter, you are not going to be back to the prompt until you close all the parentheses. So until you finish the instruction. This example, I can put everything in one line, work, is too long. I can press enter in any place and the computer, your interpreter, is going to allow you to continue working until this parenthesis here close. That is the one that closed this one. The computer knows that the instruction is complete. Now it's going to run it. It's going to give you a result. So in this case, hopefully the final result is true. Similar, you can put together instruction printing. That is something that we mentioned before, and any other thing like an addition. The only thing that I need you to remember, every single time that you use the print, be aware that you're going to have two times the result on the screen. One, because the print is the action of the print. The second one, because you always print the returning value of the function. Print instructions return the same thing that is printing. Every single time that you use print with your local interpreter, you're going to have the result twice. If you are running the online one, you are going to have only one. Moreover, if you are running the online one, the only way here for print the result is you need to add a print instruction. Remember, the online one, the one that I showed you, do not print by default results. So you want to print the result, you want to get this T on the screen, open parentheses, put a print, all the things that I give you here, and close parentheses. So use the full instruction as a parameter for a print instruction for the online one, and you can show the result if you want to show the result line by line. Anyway, if you create an instruction, use this one only with integers. Always, 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 if possible, the virtual machine is going to try to give you a fraction instead of the floating point, as we discussed before. So something like this one, all this is going to give you that fraction. So different examples of list and recursion with lists. You can put list as a parameter to other lists. I show you some mathematical functions, predicates, the one that return true or false, print, subsequent, uppercase strings, and so on. Parameters, atomic parameters, other lists as a parameters. So far, any question, guys? Very good question. What happens if I have a print instruction? What do you think? Number one, is it going to work or not? Print, return, the same thing that is printing. So I am going to print high, and I am going to return high. Makes sense, right? Key idea, everything in Lisp is a function. Key idea, every function return something. Good? Next step, guys. Okay, we have values and we have functions, instructions. What happened with for loops, if else, and what I can do to create my own functions. Those three topics, loops, conditions, and how to create our own functions, we're going to review it next lecture. Good? Any other question, guys? Okay, see you next lecture. Thank you.